Okay, so we're still finding equations of graphs that are given, and we're given this graph here. This one's sloping down, it's got an asymptote. Well, asymptotes tell us something already, and they've actually, in this case, given us the form of the equation. For the exponential functions, they always are. So we know this is exponential because of the shape of what it looks like, going down like that. Now, in our heads, we know that kind of an exponential normally looks like that, but this one looks like it's doing the opposite. It's going that way around. So it's like it's been reflected that way. Therefore, k should turn out to be a fraction, because that's how our fraction exponentials look like. But it should come out in the wash in the algebra. What is our q doing? And I'm like a stuck record on this, aren't I? What is q doing? Q is moving things up and down. Same applies here. So we've got this asymptote at -3. For an exponential function, this asymptote is here at y equals 0. So clearly everything's moved down by -3. So if y equals kx plus q, q moves things up and down, and it's at -3, well then y equals kx minus 3. We've taken our graph and moved it down by 3. Okay, what do you think we're going to do? I mean, if you've watched A and B, or you know how to do these, you're going to go, well, there's a point here. Why don't we just substitute it in? It seems to work so well. You know what? I'm with you. Y value 1 equals k to the power of x is -2 minus 3. Cool. Looks like we're going to have a bit more work to do. And a few of you took some interesting roots here, which I thought was quite cool. So we're going to add 3 to both sides. I think that's going to go k to the -2. Some of you might have just whipped out your calculator and tried some numbers. Some of you thought, no, I know my exponents. So if that's a negative exponent, this is the same as 1 over k squared. And this is 4. So from here, I don't know, there's so many ways to do it. But why don't we just keep going with this idea of multiplying by the denominator times k squared over 1 so that they cancel. And then whatever you do on one side, do on the other. So on the left hand side, 4k squared. These we said cancelled, so 1 times 1 over 1, well, it's 1. Divide both sides by 4. K squared equals a quarter. What when you square it gives you a quarter? Or what's the square root of a quarter? Square root of 1, 1. Square root of 4, 2. K has to be a positive value, so we're going to disregard any negative solutions. And y equals, I said that was a half, so let's put it in brackets just to emphasize that it's that whole fraction to the x. And I think our k value, yeah, -3. Cool, so we found equations of a few graphs. And we followed the same principle pretty much each time. What type of function is it? What does the general kind of shape look like, or the general equation? Find something, substitute in. So it seems very similar kind of process that we're doing for each one. And in fact, it seems like a very similar process to what we were doing when we were drawing the graphs in the first place. And there is quite a link. So the more you can think of it in that kind of same general terms, the better, rather than, hey, this is a special case where we do something. Anyway, enough rambling. Let's keep going.